Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. This is an example of ideal Brayton cycle. A gas turbine power plant operating on an ideal Brayton cycle has a pressure ratio of 8. The gas temperature is 300 Kelvin at the compressor inlet and 1300 Kelvin at the turbine inlet. Sketch TS diagram and determine the gas temperature at the exit of compressor and the exit of turbine, backwork ratio and thermal efficiency. So this is the solution. First thing first, you have to sketch the schematic diagram. The component of Brayton cycle consists of compressor, combustion chamber and turbine. Next, you have to write down the state. State 1 is at the entrance of compressor, state 2 at the exit of compressor, State 3 at the entrance of turbine and state 4 is the exit of turbine. For your references, at the compressor there will be W in and at the turbine there will be W out and at the combustion chamber is Q in. Okay, next we go to the TS diagram. First thing first, sketch the vertical versus horizontal T and S. Okay, from point 1 to point 2, the temperature will increase. Therefore, we draw the vertical line 1 to 2. 2 to 3 is in combustion chamber where there will be a Q in. And the maximum temperature will occur at the state 3, which is at the entrance of turbine. Okay, since the gas will enter the turbine, the temperature will decrease to T4. Okay, then from this TS diagram, we have to draw the arrow to show the direction of the cycle. Okay, next, to answer question 1, T2 and T4, okay, for T2, since this cycle is using an air, therefore we can use formula hijau. This is the formula hijau which relates temperature and pressure. T2 over T1 is equal to P2 over P1 to the power of K minus 1 over K. P2 over P1, as we learned in our previous lecture, is pressure ratio, and in this question, pressure ratio is given as 8. Specific heat ratio for air is 1.4 if I refer to A2. Okay, then from this formula, I will get T2 as 543.42 Kelvin. Please make sure the temperature must be in Kelvin. The same formula we use to solve the question for T4. Okay, but we just change the state. T3 over T4 is equal to P3 over P4 to the power of K minus 1 over K. P3 over P4, if we can see here, okay, if we sketch the PV diagram, we know that P2 is equal to P3 and P1 is equal to P4. And we can say that the pressure ratio is 8. Then from this formula, I rearrange, then I will get T4 as 717.68. Next question is backwork ratio. Backwork ratio is the ratio of work of compressor over work of turbine. Work of compressor, if we can see here, is Cp T2 minus T1 over Cp T3 minus T4. I cancel out Cp and I will get the formula like this. I replace all the temperature with the value and I will get the backwork ratio is 0.418, which means 41.8% of the work of turbine is used to drive the compressor. Next is thermal efficiency. Okay, thermal efficiency of a Brayton cycle. It is the same formula we use in Rankine cycle, W net over Q in. So this is WT, which is CP T3 minus T4. WT, work of turbine, minus work of compressor, CP T2 minus T1 over Q in, CP T3 minus T2. Then I cancel CP and I will get the thermal efficiency as a 44.8%. Thank you.